Welcome to the session on logic. Hypothesis. A hypothesis is a solution to a problematic situation which entails a set of consequences testable in experience. A hypothesis is an attempt at explanation, a provisional supposition made in order to explain scientifically some fact or phenomenon. Scientists are not content to formulate isolated hypotheses to explain the sets of facts in an ad hoc manner, but they seek to interrelate a set of hypotheses into a system which becomes a more general hypothesis or a theory. Hypotheses refer to all or to a given part of a class of objects. It is of two types: 1. General hypothesis and 2. Statistical hypothesis. A general hypothesis is applicable in a uniform manner to all members of a class under a specifiable set of conditions. Statistical hypotheses are used throughout the physical and social sciences and in many other areas of investigation. A statistical hypothesis asserts that within a given class of events, a specifiable percentage will also be a second class of event. It is supported by verifiable evidence. The collected evidence is analyzed and the process is highly complex. Hypotheses that can be tested directly are sometimes called experimental or empirical hypotheses, and those that can be tested indirectly are called theoretical hypotheses. A hypothesis is not a final assertion. It is only an attempt on the part of the observer to explain the phenomenon by looking at possible cause of it. So, it is the explanation of the cause of the phenomenon under investigation. In inductive process, formation of hypothesis is the second step. There are some basic steps like formulation of hypothesis, the determination of its consequences, the testing of its consequences, and the evaluation of its acceptability. 1. Formulation of a hypothesis. In the formulation of hypothesis, the insights, information and techniques gained in previous experience are focused on an immediate situation. The hypothesis needs to be stated in a form conducive to the determination of conditions that would count as instances of its confirmation or its invalidation. Both formulation and testing of hypothesis are controlled by factual considerations. Imaginative thought by experienced investigators aware of a set of factual conditions becomes a source of many sound hypotheses. These imagination give rise to a new concept and organize the data in a novel manner, a new technique of analysis. According to Whitehead, the true method of discovery is like the flight of an aeroplane. It starts from the ground of a particular observation. It makes a flight in the thin air of imaginative generalization, and it lands for renewed observation rendered acute by rational interpretation. In the investigation of a problem, alternative hypotheses can be also formulated, either initially or successively. If several different hypotheses continue to offer relevant solutions to problems, the most promising are selected for further testing. There may be more than one hypothesis at a time to explain a particular phenomenon. Then, trial and error are required for the elimination of unsatisfactory hypotheses. Newborn hypotheses in science can range from closely reasoned projections to wild guesses. Sharp insight, adequate formation, seasoned intelligence, and keen imagination contribute to the formulation of fruitful hypotheses. The experience and sensitivity of the investigator may be more important in specific cases than any formal criteria for selecting the proposals. Among these, some hypotheses may require months and years of testing as they approach the very satisfactory verification and refinement. 2. The determination of the consequence of the hypothesis. Any proposed scientific hypothesis has certain anticipated consequences. Identification of these consequences is an essential step to establish the trustworthiness of the hypothesis. The statement of the proposed consequences is offered as a deduction from the hypothesis. If the hypothesis holds, then the deduced consequences confirm its soundness. Inductive inferences, either in the form of simple enumeration or of analogy, suggest clues for the formulation of hypotheses and for the elaboration of their implications. The same may be used in other situations as the expected consequences of a hypothesis to be tested. For example, the appearance of muddy water and of chunks of wood and brush in a river may suggest the hypothesis of a rise in the water level. If the hypothesis of a rise in the water level is made, the implications of the hypothesis would include a muddying of the water and the appearance in it of chunks of wood and brush. 3. Testing the hypothesis to determine whether its anticipated consequences hold. The hypothesis formed in the course of analysis must be verified by relating them to actual facts. Testing the hypothesis requires anticipated consequences of the hypothesis hold. In the experimental sciences, such testing includes purposeful observation, careful measurement and effort at producing a set of consequences or events that confirm or disconfirm the hypothesis. The method of verification can also be used. It helps us to select the correct hypothesis. With the help of observation and experiment, the hypothesis can be at once verified with reference to the actual event. This is known as direct verification. In indirect verification, we at first assume the hypothesis to be true and draw or deduce certain conclusions from it. Then, the deduced consequences or conclusions must be compared with actual events or facts. If the deduced conclusions or consequences are in agreement with actual facts, the hypothesis is said to be true and is verified. If the deduced consequences are not in agreement with actual facts, then the hypothesis is either eliminated or altered. 4. Evaluation of the acceptability of the hypothesis. The acceptability of the hypothesis must be determined by the investigator by examination of a number of factors. Basic considerations include the degree of confirmation provided by testing of the anticipated consequences, the significance of additional independent evidence, and the success of the hypothesis in solving the problem for which it was designed. On the basis of such considerations, the investigator may accept the hypothesis, reject it, modify it, recommend further testing, or formulate alternative ones. A reliable hypothesis should be supported by evidence not immediately related to the experiment designed to test its acceptability. Such evidence includes other prevailing and accepted theories in science as well as data collected in other scientific experiments. A basic reason for corroborating a hypothesis by data and theories other than those derived from the immediate experiment is to avoid prejudicial ad hoc hypothesis. Ad hoc hypotheses account for events or conditions retrospectively. A prejudicial ad hoc hypothesis either has no explanatory power or is limited to the particular set of cases for which it was invented. Again, a hypothesis is not to be rejected merely because it is ad hoc, but in such cases further analysis and testing are required. The aim is to find definite reasons either for its rejection or for its acceptance. We can avoid prejudicial ad hoc hypothesis by providing experimental means for testing the explanatory power of a hypothesis by finding a basis for its incorporation into a structure of other scientific theories and hypotheses, and by relating it to more than one set of facts or events to which it has predictive relevance. If a hypothesis is reliable, then it should be able to solve the problem that gave rise to its formulations. But it is possible for a hypothesis both to have confirming instances of its proposed consequences and to solve the problem that gave rise to its formulation without being finally acceptable. Its usefulness in solving a particular problem is not a sufficient condition for accepting it as reliable. The criteria for evaluating a sound hypothesis. There are some criteria for the appraisal of hypothesis, whether it can be accepted or eliminated in the creative work of scientific inquiry. They include: 1. A sound hypothesis serves as a useful instrument in guiding research. 2. A sound hypothesis is confirmable. 3. A sound hypothesis is the simplicity of the hypothesis itself. 4. A sound hypothesis provides an explanation for a given set of events at least as efficient or satisfactory as any alternative hypothesis. 5. A sound hypothesis needs to be inclusive. 6. A sound hypothesis needs to be supported by data other than immediate experiment. 1. A sound hypothesis serves as a useful instrument in guiding research. In science, the primary duty of ideas is to be useful and interesting even more than to be true. According to Claude Bernard, without the original guiding hypothesis, the experimental fact which contracted would never have been perceived. They should have value of theories which make use of them as intellectual tools necessary to the evolution of science and suitable for the discovery of new facts. The hypothesis should both further inquiry and focus attention on the direction that the inquiry takes. 2. A sound hypothesis is confirmable. It should be possible both to state what consequences can be expected from a reliable hypothesis and to test these consequences in experiments. One should be able to state a set of conditions that would constitute sufficient evidence for the rejection of the hypothesis. 3. A sound hypothesis is the simplicity of the hypothesis itself. Simplicity is a relative term. It includes not only the language of the statement of the hypothesis, but also the number of other assumptions. Other things being equal, the fewer the assumptions involved, the stronger the hypothesis. Simplicity of the hypothesis includes the technical problems related to its confirmation and its applicability in resolving the problematic situation that gave rise to it. 4. A sound hypothesis provides an explanation for a given set of events at least as efficient or satisfactory as any alternative hypothesis. It is preferable for such a hypothesis to provide an even more satisfactory explanation. For example, Kepler's hypothesis establishing that the orbits of the planets are ellipses rather than circles or epicycles was not only simpler, but explained the behavior of planets such as Mars in a more satisfactory manner. 5. A sound hypothesis needs to be inclusive. It should account for all relevant cases that are instances of its application and for any apparently negative instances. 6. A sound hypothesis needs to be supported by data other than immediate experiment. A sound hypothesis also needs to be corroborated or supported by data other than those found in the immediate experiment and by other theories that have been repeatedly tested in the area. Bernard's revised hypothesis about the control of blood circulation exercised by the sympathetic nerves provided the foundation of many other subsequent theories. Problems in testing the consequences of hypothesis. A troublesome logical problem in testing the consequences of a proposed hypothesis takes the following form. If the hypothesis H is true, the consequences A, B and C are true. Consequences A, B and C are true, therefore, the hypothesis H is true. This logical form affirms the consequence of a hypothetical proposition and then proceeds to affirm the antecedent. This is a formal fallacy. This recognition of formal fallacy does not justify a rejection of the procedure, but suggests its use and reveals the difference between confirmation of a hypothesis and a formal demonstration of its truth. Carl G. Hempel proposes a paradox regarding the confirmation of hypothesis. He argues that any evidence can provide confirmation of a hypothesis such as all ravens are black. An equivalent form of this statement is all non-black things are non-ravens. He holds that any evidence confirming an equivalent statement also confirms the original statement. Thus, to find an object that is not a raven and is not black provides confirming evidence to the hypothesis all non-black things are non-ravens, and to its equivalent hypothesis all ravens are black. His emphasis here is that in a classificatory or qualitative concept of confirmation, this paradox holds on syntactical grounds. Thus, Hempel's paradox points to the importance of determining the different kinds of consequences of a hypothesis that are relevant for its confirmation and of indicating the kinds of condition that would count against its confirmation. It is also significant that the kind of generalization chosen by Hempel to illustrate his experiment is based upon symbol enumeration. It is less adaptable to hypothesis having a variety of consequences testable and proved through experimentations. Different types of hypothesis. 1. Working hypothesis. Working hypothesis is an assumption or an explanation which can be verified and can be found to be true or false after verification. It is legitimate and meaningful hypothesis. It is a stepping stone in the onward march of the intellectual progress. A working hypothesis need not be always true. Its truth or falsity can be established only after verification, but a working hypothesis is always verified. When it is contradictory, it is called a barren hypothesis. 2. Barren hypothesis. Barren hypothesis means a meaningless and invalid assumption about the cause of an observed phenomenon. It is an irrational explanation. It cannot be verified on a rational ground, so its truth or falsity cannot be established. A barren hypothesis is not a legitimate one. It is opposite to a working hypothesis. From a barren hypothesis, we cannot infer any meaningful or valid assumptions. 3. False hypothesis. False hypothesis is different from a barren hypothesis. It is a legitimate and working hypothesis. It is verifiable, but after verification it is found to be false. A false hypothesis is rejected and a new one is framed in its place to explain the phenomenon. It can be stated that a false hypothesis is always capable of verification, but it fails the test of verification. So, its value ends with verification. It is an unsuccessful hypothesis. Even though it is legitimate, it happens to be unfitting on verification. In the field of scientific studies, quite a lot of hypotheses are framed, but as many are rejected as false hypotheses. When a hypothesis is found to be true after verification, it is accepted as a theory. A theory is a hypothesis that acquired a higher status by verification. So, compared to a false hypothesis, a theory has a very high value in the process of inductive inquiry. It is a true hypothesis. When a theory is proved and established beyond doubt, it is called a law. This general law is the final product of induction. Crucial experiment. Inductive process consists of 4 different stages. It starts with the observation of facts. In the second stage, a hypothesis is formulated on the basis of these facts. In the third stage of verification, the hypothesis is tested to find out whether it is true or false. When a hypothesis is found to be true, it will be accepted for further examination. To establish the final validity of a hypothesis, something more than mere verification is needed. Sometimes, more than one hypothesis may be put forward to explain the same phenomenon. They are called the rival hypothesis. Among these rival hypotheses, only one will be essentially true and valid. To decide between these rival theories or hypotheses, it is necessary to make use of the crucial instance. The word crucial is derived from the Latin word crux, which means cross. When we are at a crossroad or junction, the signpost may help us to find out the right direction. These signposts are the crosses. In other words, crosses helps us to adopt one road at the cost of the other one. Similarly, the crucial instance helps us to decide between 2 rival hypotheses. In induction, crucial instance helps us to decide between 2 rival hypotheses. In induction, crucial instance is the phenomenon or the event that can be explained by only one of the rival hypotheses. The other can be rejected. Sometimes, we have to depend upon certain experiments to find out the final validity of one of the hypotheses. Here, the crucial instance is obtained by the experiment. The crucial instance thus obtained can be called a crucial experiment. When the ultimate validity of a hypothesis or a theory is established beyond doubt, it is called a law. In the field of scientific theories, crucial experiments play an important role. Now, let us summarize. This session highlights the importance of hypothesis in the process of inductive reasoning. A proper definition and the conditions of a valid hypothesis is also explained. The criteria for determining a sound hypothesis is also important in scientific reasoning. There are 3 types of hypothesis, namely working, barren and false, each differing from the other. The importance of crucial experiment in the process of inductive generalization is also explained in detail. There are a few assignments for you to work out. 1. To verify a hypothesis is not proof. Explain. 2. What is the difference between a barren hypothesis and a false hypothesis? 3. The story of induction is a story of hypothesis. Explain. 4. How is a hypothesis verified? You can refer following books for further study. 1. Kilgore J. William, An Introductory Logic, Reinhardt and Winston Publishers, London 1968. 2. Sullivan J. Daniel, Fundamentals of Logic, McGraw-Hill Book Company, New York 1963. 3. Cohen R. Morris and Ernest Nagel, An Introduction to Logic and Scientific Method, Allied Publishers, New Delhi 1976. 4. Copy M. Irwin, Introduction to Logic, Macmillan, New York 1982. 5. A Textbook of Logic, SCRT, Thiruvananthapuram 2003. Thank you for watching this program. Let us meet in another session with another topic. Till then, bye.